Good afternoon all. I'm Dr. Abdul Pasha, Assistant Professor, Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So this is about the course Power System Operation and Control. Here I'm going to discuss about the topic called Fundamental Characteristics of Excitation System. So earlier we have discussed what are the characteristics, basic features of the excitation system and IEEE basic simple definitions related to the synchronous machine concepts. So here it will discuss about how the elaboration of characteristics will be done for a given excitation system. Those are the aspects we'll cover for this today's. So some of the fundamental characteristics are derived for dealing with the excitation system. The first one is function. So what is a function? Means an excitation system's primary function is to provide a continuous DC current to the field winding of the given synchronous machine. So this current creates a magnetic field on the rotor, so which controls the output voltage of the generator case. Here the main objective here is an excitation system usually depends upon the application oriented cases. So what are that means? For example, for synchronous generators or alternators, so here the objective is to maintain a constant terminal voltage. So alternators will produce the voltage under constant terminology. Then the components associated with this are typically includes an exciter, power system stabilizer PSS, automatic voltage regulator AVR, processing unit PU, measuring elements. Some simple measuring elements for the measurement of voltage, current, power and frequency related terms we are going to treat measuring components. So what are the basic types or classification involved? Means there are two general classifications of the excitation systems. One is rotating exciters, another one is static exciters. So what are rotating exciters and what are static exciters we will discuss. So control. What is the basic control here for the excitation system? Means the control system that regulates the field current. It is known as excitation control system. Factors. Usually the excitation of a synchronous machine depends upon the machine speed, load current and power factor. So these are the factors much more influenced for the excitation of a synchronous machine. And they will depends upon the speed, load current and power factor. Means here the excitation levels are supposed to be maintained within the prescribed limits. So excitation system is ready to excite the armature by creating a magnetic field on the rotor. This will be done through the DC current. So output voltage of the armature is supposed to be varied with the strength of the magnetic field provided. That means excitation system controls the output voltage of the generator. This is done by adjusting the DC current to the generator field winding. So usually this may happens repeated manner. So the features of excitation systems of the synchronous generators plays key role in the power system stability network. So excitation systems are which are responsible for providing the necessary field current to the generator's rotor winding to ensure stable and synchronized output voltage. So it incorporates various features that contributes to efficient and reliable operation of the system. This may result to the suitable working of the whole system. So this is the basic diagram representing how excitation system is provided So this is AVR DC output to the exciter stator case, and here is our exciter with the rotor and stator are going to be coupled in nature. This is the device called automatic voltage regulator connecting to the block of exciter with in addition to the rotor and stator case. This is one of the rectifier element which will be coupled to the one of the shaft of the main rotor case. That means bearings are provided here. So these bearings will use suitable smoothing or removing the surface tensions of the system cases. One of the fan is connected across this means which will ready to extract the heat from internal surfaces of the machine. So this will cool down all the temperature cases. Here AVR power source and sensing from alternator output is going to be treated here. So this will be treating to the main stator cases. Voltage regulation. What is voltage regulation means? Controlling the voltage or maintaining the output voltage. So one of the primary features of the excitation system is that controlling the voltage or voltage regulation. So it monitors the generator output voltage and adjusts to the field current. That should be done according to maintain a constant and stable voltage levels. So the features ensures that generated voltage remains within the acceptable limits during varying load conditions and disturbance cases. That means which will prevent from voltage fluctuations that could impact the connected equipment easily. Reactive power control. So we discussed already this concept, reactive power control, how we control the reactive power, what are the key features about the reactive power controlling parameters. So excitation system allows for precise control of the generator's reactive power output. That means by regulating the field current, it can adjust the generator's reactive power contribution. That should be connected to the grid case. So these features of excitation systems are very crucial in nature for supporting to the transmission of active power, maintaining voltage levels and ensuring power factor correction in the whole electrical network or electrical power system. Stability enhancement. What is stability enhancement means? This is the important aspect of the excitation system. That means this is the ability to enhance the stability of the synchronous generator and the overall power system gain. So it responds very widely to sudden load changes or disturbances in the network. That means which will provide the required field current to prevent the generator from slipping out of the synchronism without the grid connection. So these features of excitation system may helps to maintain the system stability and also preventing the cascading failures. So due to which the field current limiting is going to be treated. So which are acting as one of the key features of the excitation system, which may includes protective design and to limit the field current within the safe operating boundary region. So these are the key operating boundary regions of the field current limiters. So there should be excessive field current which may leads to overheating and damage of the generator. So this feature ensures that field current remains within the generator's thermal limits. So which may be prompting to the operational reliability cases. So digital control and monitoring method is also introduced here. So that modern excitation systems are regularly considered with the featured digital control and monitoring capability systems. That means digital control allows more sophisticated regulation algorithms. So they have better response to the system changes. Is there any sudden changes in the system conditions? The response given from the digital control and monitoring systems are very effective in nature. Additionally, we have digital monitoring enables that real-time data collection and diagnosis, facilitating predictive maintenance and fault detection is possible here. That means redundancy and reliability is aspected here. So to ensure that high reliability, many excitation systems are equipped with redundant components. So what are those redundant components means? Here, that redundancy is going to reduce the risk of the excitation system failure. That means which will enhance the generator's overall availability. So when one component is going to be fails, the redundancy one can seamlessly take over, that minimizing the downtime error. Because of this, the response of the system is more, and the redundancy will reduces the risk assessment of the whole system. So this may ensures the high quality of the excitation equipment and with reduced redundant component levels. So which may seamlessly take to the system as reducing the error coefficients. Excitation system models and variants. What are the various models and variants? Means various excitation system models and variants exist. Here are to cater to different generator types and applications. Means different generator sizes, designs, and grid requirements may call for specific excitation system configurations. So the manufacturers, they will offer a range of models, each tailored to suit various power generation scenarios, which may goes to hike to the levels of the extent. Then they may lead to the generation coefficient constants to the variable levels. Integration with power system stabilizers. What are integration with power system stabilizers? Or PSS means excitation systems can be integrated with power system stabilizers. This will be dampened to lower frequency oscillations and also improves the system stability. So here the PSS will measure the system oscillations and sends appropriate signals to the whole excitation system, which will ready to modulate the field current and dampen the oscillations to the particular frequency levels. So these oscillations may be frequently happens to the whole response of the system. So this may be considered to the next level of the system. Grid code compliance. What is meant by grid code compliance? Means features of the excitation system, they must comply with or amalgamate with the specified grid codes and regulations. So what are the specific grid codes and regulations? Means grid codes which will define technical requirements for the power generations, including voltage and frequency control. So excitation systems plays a vital role in meeting these standards, which may ensure seamless integration with the power grid that should be connected to the system. So these features are, along with the redundancy and compliance with grid codes, they contribute to the overall stability and performance of the whole power generation system. So excitation system models and variants, they can cater to the diverse applications, which may provide tailored solutions for various generator types and operating conditions. This may give the suitable results. Here is a numerical problem that defines how the generator excitation system follows. So that we will discuss now. So how do you calculate the excitation voltage and current for the synchronous generator? Synchronous generator is nothing but here is a simple alternator. This is a simple alternator. Here our aspect is to calculate the excitation voltage and also excitation current. Excitation voltage and excitation current for the given generator. So for example, we say that voltage will be 103.1 volts DC and 14.5 amps DC for 10.59 MVA. So like that the problem is given, and it is also coordinated with 9 megawatts with 11 kV of 50 Hz generator. This is the frequency range and voltage ranges are given. So calculation of the steady state field voltage and current for a given load, that can be made by using the V curves only. That means for that particular information, the synchronous generator must read this portion. So here we should treat V curves. So this V curves will give the total information regarding the synchronous generators of the excitation system. So these are the V curves. These V curves are drawn in between field current versus armature current of the given alternator or synchronous generator. Field current versus armature current. So here per unit power outputs are given. Those are starting from 0 here. Per unit power outputs. And 0.25. This is the second curve. 0.25. 0.5. Third curve. 0.75. 1. So these are the variants which may introduced as power per unit power outputs, which are 0, 0.25, 0.5, 0.75 and finally 1. So totally how many means? 1, 2, 3, 4, 5. Totally 5 per unit power outputs. Totally 5 power unit power outputs. For this, we need to observe the coefficients with the leading power factor like this, which is about 0.8 leading, and 1, that means unity power factor, and lagging case is about 0.8 power factor. So 3 power factor ranges are treated for the V curves of the synchronous generator. One is about 0.8 lead, another one is 0.8 lag, finally unity power factor range. This is treated as unity power factor range. So according to that, the development of the V curves are based on the given per unit power output criteria. So which may be existing in leading power factor case, lagging power factor case and unity power factor case. Irrespective of that, the per unit power outputs, 3 cases of the power factors are influenced easily. So from the above problem here, for this problem we are writing for the given information as synchronous generator rating. So the rating is provided as a 10.59 MVA. Rating is given in MVA. Real power is given in 9 megawatts. Voltage is given in 11 kV, that is 11,000 volts. Frequency about 50 Hz. So nominal frequency is applied. Excitation voltages are given about 103.1 volts. So this excitation is DC in nature, that we already know. And excitation current is 14.5 amps DC. So this is excitation current is IF, excitation voltage is EF. So these are the excitation voltages and excitation currents. Now calculate the excitation voltage first case. So excitation voltage E suffix F can be estimated based on the generator's operating condition. So primarily its terminal voltage V and the synchronous reactance excess of the generator are depends. That means the formula derived for the excitation control voltage in a synchronous generator is EF equals to V plus J IA excess. So here EF is the excitation voltage, which will be treated as internal voltage, V as the terminal voltage, IA as the armature current, XS as the synchronous reactance. So these coefficients are must treated when we are supposed to analyze the numerical case. Now calculating the armature current case, here find the armature current IA. We can use the apparent power as S and the voltage as V. Then S equals to V into IA. V into IA will be considered. V into IA. So where S is the apparent power in volt amps or kVA. So now given that generator rating S equals to 10.59 MVA, which is about 10,590 kilovolt amps, which may be written as 10.59 MVA, right? So current can be calculated as IA equals to SC into V. This is the current to calculate armature current. Now substituting the values, where SC is about 10.59 MVA, and what about V? V is about voltage 11 kV. So when you make the product of these two coefficients, 10.59 into this 11 kVA will results to 963.64 amps. This is the resultant we will see. Here we should assume the quotient that synchronous reactance will be 0.1 ohms, then voltage drop becomes 963.64 amps. That means which may existing at 0.1 ohms means 96.36 volt is considered as voltage drop. That is voltage drop here treated with the current into this resistance as V equals to I into R. Then I and R coefficients must be multiplied. Here also 963.64 into 0.1 ohm resistance is considered. Then your voltage becomes 11 kV plus 96.36. So this is the given voltage 11 kV, 96.36 is the voltage drop. This is the applied voltage. So when summing these two, you may get 11,096.36 volts. This is the final redundancy voltage that we supposed to calculate for the given excitation of the generator system. So this way makes the system parameters are most suitable to undergone with the system condition. So if you want to abruptly change the system parameters from the initial values means the relation that is EF equals to V plus J IA XS may goes to changes. So instead of which you need to maintain the armature current and terminal voltage as constant. So when you are maintaining these parameters with respect to the internal voltage, then excitation voltage can be easily estimated. That is based on the usual generator operating conditions. So primarily its terminal voltage and synchronous reactance V and XS becomes constant for the given generator set. So they are going to be treated with respect to the given absorption of the system. So that gives the suitable results for excitation of the generator system. So these are some of the references whichever I have considered, and the documents related to this system may abruptly explained in this video lectures. So that gives the more information in these cases. And finally, thank you.
Like, share and subscribe. Hit the bell icon for more updates.